Hello. Today we're practicing some wave equation problems. Okay, so let's jump right into it. Here's our first problem. Violet light has a wavelength of 4.10 times 10 to the negative 12 meters. What is the frequency? Well, that is our wave equation. C stands for speed of light equals wavelength times frequency. Pretty simple. Okay, there's our speed of light. That's our constant. Every time we see the letter C, that is the number we're going to plug in for it. Solving for frequency means we need to rearrange the equation to get frequency by itself. How do we do that? Oops, typo, ignore that. How do we do that? We need to divide both sides by wavelength. After doing so, we are left with this. Frequency equals C divided by the wavelength. Plug and chug. Let's just plug in our values. And there is our final answer. Okay, so you are going to have to know how to type in scientific notation on your calculator. And then our unit for frequency is hertz. Let's do another one. Green light has a frequency of 6.01 times 10 to the 14th hertz. What is the wavelength? Again, our wave equation. There's our speed of light constant. And again, we need to rearrange it to solve for wavelength, okay? So the problem gives us frequency. So when we rearrange, that's what we divide by, frequency. We're left with this. Plug in our values, and there's our final answer. Wavelength, right? Length. So the unit is meters for wavelength. There is a second equation that we're going to have to learn how to do, our energy equation. So let's get right to it. Calculate the energy of a photon of radiation with a frequency of 8.5 times 10 to the 14 hertz. There is our energy equation. E for energy equals H times frequency. H is a constant, Planck's constant, 6.626 times 10 to the negative 34 joules per second. So every time we're using the energy equation and we see the letter H, plug in Planck's constant. Okay, no rearranging needed. It's just straight up plug and chug. It's asking for energy, and our equation is already set up to solve for energy. So plug in Planck's constant for H, and the problem gives you frequency, multiply, and there's our final answer. Our unit for energy is joules, okay? Capital J for joules. 5.6 times 10 to the negative 19 joules. Let's do one more. This last one's my favorite, and you'll see why. What is the energy of light whose wavelength is 4.06 times 10 to the negative 11 meters? This one is a 2-for-1 because looking back, if you look at the energy equation, there's no place to plug in wavelength. Okay, and yet the problem gives us a wavelength and it's asking us to solve for energy. How do we do that? Okay, here's how we do that. We're going to be using both equations. That's why it's a 2-for-1. One problem, two equations. We're going to use the wave equation to solve for frequency, then plug that frequency in to the energy equation. So first up is the wave equation. We cannot solve for energy unless we have frequency. And we need to use the wave equation to solve for frequency. Okay, so there it is again. Okay, there it is rearranged. Frequency equals C, speed of light, divided by wavelength. Okay, there's our constant for the speed of light, remember? And then the problem gives us the wavelength. And there is our frequency. Now that is not the final answer, okay? We just needed that to get the final answer. So next up is the energy equation. Remember the energy equation, H times frequency. So I'm going to take this 7.4 times 10 to the 18th hertz, and I'm going to plug it in right there for frequency. Okay, there is Planck's constant again, and this is the frequency we just figured out with the wave equation. And there's our final answer, 4.9 times 10 to the negative 15 joules. Okay, feel free to pause, rewind, fast forward, view any parts of this video again, but these two equations are pretty simple. This last problem is as complicated as this will get. Okay, I promise you, no tricks, plug and chug. Thank you for watching, and I'll see you next time. Bye.